So title those notes, regular polygons. We're going to find the area of a regular polygon. New formula coming your way. What does it mean if a polygon is regular? Because that's really important. Yes, very good. Equilateral and equiangular. All sides congruent, all angles congruent. So today, the formula we're going to learn only works on a regular polygon. You cannot use the formula unless the polygon is regular. But don't worry, all of our polygons today will be nice and regular. So I would not write this down in my notes because that is old news. You're welcome to if you feel like you need to. A regular polygon is a polygon in which all sides are congruent and all angles are congruent. Okay, now we're going to get some new words. I drew two segments. There's one in that green picture and one in the red picture. What do you think an apothem is? Everyone stop real quick and say apothem to yourself. Apothem. So it's like you're saying apple. I feel like I'm teaching like kindergartners. Apple. Apothem is the correct way to say it. Some people say apothem. It's kind of like potato, potato. Oh, very good. Very good things that y'all are saying. So the apothem is the segment that goes from the center of the polygon to a side. And it doesn't just go to the side in any sort of matter. Y'all said that. It has to head towards the side in a perpendicular manner. So the perpendicular distance from the center of the polygon to a side. So it's a segment. That's a very specialized segment. Write down that definition. Good. All good. All right. So we already have that an apothem is that segment extending, I liked that word, from the center to a side. So what's a radius? A segment is the distance between the center and a vertex or an angle. Either way. Yep. I think I used the word vertex. Yep. The distance from the center of a polygon to a vertex. Because technically an angle is two rays. But we want to make sure it doesn't go to the angle, but to the vertex of the angle. So that's really important to say the word vertex. Okay, now I blew up a nice regular pentagon here, and we're going to talk about two new words. You don't need to write them down yet, but you need to just watch and listen. All right, I'm going to pull out this circle right here, and I'm going to tell you a word, and that word is inscribed. That circle is inscribed in the pentagon. That means it's inside the pentagon. Now, inscribed doesn't just mean it's inside. That circle has to be touching every side of the pentagon. Is it touching all the sides? Touching, 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 touching. Okay, touching all 5 sides. So that's called an inscribed circle. Now, notice, the radius of the circle is the apothem of the pentagon. You see that? The radius of the circle, and we're just assuming that this is the center. That's okay. The radius of the circle is the apothem of the pentagon. Okay, so that's how we come up with the apothem. Now, I can also put the circle outside the pentagon. That's as good as I can do right now. Okay. Oh, I ungrouped it. I hate when I do that. And that is called circumscribed. I grouped it back together. Okay, so when the circle is inside, it's called inscribed, and when it's outside, it's called circumscribed. So circumscribed and inscribed. Notice, in the circumscribed circle, the radius of the circle is also the radius of the pentagon. Now, if I juxtapose these, if I put them all into one picture, I notice that something is formed. Something really important is formed. Because we know how to find the area of a right triangle, correct? So, I notice that the apothem, the radius, and this segment right here form a right triangle. When I said and this segment right here, what does that represent? It is half of a side. So if this is the side of the pentagon, this is 1/2 of the side. That's really important because a lot of people do all this work and they find that segment and they think it's the side of the shape, but it's not the side of the pentagon, it's just half of the side. Okay, I want you to write down these two situations. That way you get these words in your notes. I want the word inscribed in your notes and I want the word circumscribed in your notes. So I want you to write the description and draw the picture, then write the description and draw the second picture. I'll give you time to do that. So you don't need to memorize, oh, when the shape is inside, the radius is the radius, and when the shape is outside, the radius is the apothem. You don't need to memorize that, but you do need to know how to draw the picture. So if I were to give you that description and hide the picture from you, you should be able to draw that yourself without having to look at your notes anymore. So when you see the word inscribed, you just cross it out and you write inside. And when you see the word circumscribed, you can just cross it out and write outside. So, triangle in a circle, and then square outside a circle. And then you'll know if the radius is the radius or if the radius is the apothem based off of the picture. All right. There are three special cases when it comes to regular polygons. We love when it's a special case because it makes our life easier. Let's talk about the three special cases. Now, every time that we use the formula that you don't know yet, you don't know the formula yet, but every time we use it, we're going to be looking at that right triangle right there. That right triangle formed by the apothem, the radius, and half of the side. It's a very important little right triangle. Now, if we know the angles of this triangle, and if those angles are special, then we can use our rules to find all of the sides. So, if this is an equilateral triangle, well, then the angles are 60, and this angle was bisected, so there we go. It's a special case. It's a 30, 60, 90 right triangle, where the 30 is at one of the angles, the vertex right here. The next special case is a square. In a square is of course special because all the angles are 90, and when you divide 90 by 2, that special little triangle, our lovely favorite triangle, is a 45, 45, 90 triangle. All you need is one side, and you know all the sides. The last special case, let's see if y'all can guess it. The last special case is a hexagon. And the reason that it's special is because if you remember, the angles of a hexagon are all 120. Well, if I take 120 and I bisect that, I get 60. So it's another 30, 60, 90, but the 30 and the 60 are in different spots. In a regular hexagon, the angles are 120. How did I know that? N minus 2 times 180 divided by N. That's how I knew that the angles were 120, or maybe you memorized it. 120 divided by 2 is 60. So those are the special cases. Please write them down in your notes. Go. All right, and here we go, the formula. Yay, we made it to the formula. We're halfway through the lesson. Only write this one down. I don't think you need to write the formula for the perimeter down. That is obvious. You take the number of sides and multiply by how long they are. Okay, so the area of a regular polygon, capital A, area equals lowercase a, which stands for apothem, right? Our new word. Apothem times capital P, perimeter, divided by 2. Apothem times perimeter divided by 2. And that formula, of course, comes from finding the area of those right triangles, base times height divided by 2, kind of like that. Finding the area of one of those triangles, then multiplying it by all of the triangles. So it's kind of like the formula for a triangle, except our letters are different because we're in a regular polygon. Apothem times perimeter divided by 2. You will also see it on your formula chart, as usual, with a coefficient of 1/2 instead of dividing by 2. Let's try it out. Find the area of a regular hexagon inscribed in a circle with a radius of 4. So I'm not only asking, can you use the formula, but I'm asking, can you draw that picture? So go ahead and try to draw the picture before I reveal it. So remember I told you, when you see the word inscribed, you can cross it out and put inside. So I am wanting a hexagon inside a circle. Hexagon inside a circle. The circle has a radius of 4. Circle with a radius of 4. So the circle's radius is 4, and that's actually also the radius of the hexagon because the shape is inside the circle. Okay, so we need to work with that 4. We need to find an apothem, and we need to find a perimeter, or else we can't use our formula. So the great news is hexagon is one of the special cases. 120 divided by 2 is 60. That's how I know the 60 goes there. Because students will know that it's 30, 60, 90, but they won't know where to put the angles. So make sure you know where the angles go when you don't have your notes available. All right, the 4 is across from the 90. So across from the 30 is 2, and across from the 60 is 2 root 3. X root 3, 2x. Okay, here we go. It's formula time. Area equals, okay, apothem times perimeter divided by 2. Be careful. The perimeter is not 12. It's not 2 times 6 because 2 is not the side. And that's the biggest mistake that students make is that they don't find the whole side. They only use that 1/2 of a side, so be careful. Okay, good. So the perimeter is 4 times 6. Apothem times perimeter divided by 2. Do we put root 3 in our calculator? No way. Don't put root 3 in your calculator, okay? These 2's actually cancel, so we don't have to go to our calculator at all. 24 root 3 centimeters squared. If you didn't know that you were allowed to cancel the 2's, so you would go to your calculator and you would do 2 times 24 divided by 2, and you'd end back up at 24. Find the area of an equilateral triangle with radius 6 root 3 meters. Find the area of an equilateral triangle with radius 6 root 3 meters. This one, I don't need to give you a lot of time to draw because you don't have to inscribe or circumscribe anything. So you just draw yourself an equilateral triangle and you make sure you label the radius 6 root 3. Now we need to remember where the angles go. The angle of the triangle is 30. The angle of the triangle is 60, of course. And when you cut 60 in half, you have 30 right there. There's your 30 and your 60. Okay, 6 root 3 is across from 90. So across from 30 would be half of that. And then across from 60 is x root 3. Well, your x is 3 root 3. So it'd be 3 root 3 root 3. So it'd be 3 times 3. Oh, that turned out prettier than I thought. It would be 9. Now, students have asked me, can I just do, this is a triangle, so can I just do base times height divided by 2? Sure you can, but we don't know the height. And no, to answer your question, the height is not double the apothem. The height is not 6 root 3. This is not the center. This is not the midpoint of that segment, okay? Because that segment is actually made up of a radius and an apothem, and they're not the same length. So just be careful there, okay? We are going to just use our new formula, apothem times perimeter divided by 2. So the apothem is 3 root 3. The perimeter, be careful, is not 27. Don't do it. The perimeter is 54, right? Divided by 2. Apothem times perimeter divided by 2. Finally, so you take care of everything on the outside. You do 3 times 54 divided by 2, and then you attach the root 3 back to the number, and then you put your units. 81 root 3 is the only acceptable answer, okay? Cool. Next problem. Find the area of a square with radius 4 inches. I'll let you draw it. We've got a square with radius 4. Now, I'm going to stop you right there. Whatever you're doing to this square, stop. Because I want to show you an easier way to do this one. We don't have to stick to apothem times perimeter divided by 2. We don't have to stick to always finding the sides of that little right triangle. We can use our math brain, and we can use our resources, and we can get creative, and we can know that, Oh yeah, in a square, the diagonals are perpendicular. And so that is a 45, 45, 90 triangle. And I know the easiest way to find the area of a square is just side squared. So I can use my 45, 45, 90 rule. 4 root 2. Now I know a side of my square. I'm allowed to just take my side and square it. The area of a square is side squared. Length times width, base times height, all the same thing. So 4 squared is 16. Square root of 2 squared is 2. So the answer is 32 square inches. Now, could I have done apothem times perimeter divided by 2? Yes, but it would have been much more messy, wouldn't it have been? Isn't the apothem, let's see, the apothem 2 root 2? So it would have been apothem times perimeter divided by 2. You get the same thing, but that one's just, there's more room for error in that black formula than in the red one. All right, next one. What's the area of a square circumscribed about a circle with radius of 16? The picture is the key to solving this problem, so I want to see that you can draw the picture without my help. Draw a picture. Go. Remember, you cross out the word circumscribed. You don't need to go look at your notes. You just cross it out and you write outside. So what is the area of a square outside a circle with radius 16? The circle has the radius of 16. Now, you could really get yourself into a pickle if you draw that radius, because that radius is not helpful at all, okay? So don't draw that radius. Draw the radius that is helpful to both the circle and the square at the same time. Draw the radius that touches the square. So, and this is one of our cases where the radius of the circle is the apothem of the square. All right, and now we are not going to limit ourselves to that silly new formula because it's not helpful here. We know that if this is 16, then this is also 16. So one of the sides is 32, and so we can find the area by doing 32 squared. No need to do apothem times perimeter divided by 2. So if you could draw the picture on this one, then you were set. You just needed to know how to draw the correct picture. Okay, last one and the most important one of the day. You ready? Most important problem. Find the area of the regular polygon to the nearest tenth. Now, that should give you a clue right away. When Miss Tanton lets you round, what does that mean? There's trig involved. Yeah. So, if I'm letting you round, that means I have no choice because I hate letting you round. That means there's trig involved because you have to round when trig is involved. So, let's see how we're going to solve this one. We are going to start by drawing our favorite right triangle. In order to find the area, we know it's apothem times perimeter divided by 2. We need a perimeter. So we need to find this right here. Remember, it's only going to be half of the side. Now, to use trig, you need a side and an angle, right? So we need an angle. And there's 2 ways to get an angle. There's 2 different ways. Aaliyah got 54. 120 divided by 2, but it's not a hexagon, Ralph. It's not a hexagon. So, here's one way to get an angle. This is a pentagon. So you could do 5 minus 2 times 180 divided by 5. That would get you this whole angle, so then technically you'd need to divide it by 2. Whoa, that's a lot. Or you could do my personal favorite way. Take a look at that right there. Let's look at the other angle first. There are 360 degrees in a circle, right? Now, if I were to split this up into triangles all around, lots of triangles, how many triangles would I have? If I just drew that red triangle, but I drew it all the way around. There's 2 triangles per side. So I'd have 10 triangles, right? 10, it's pentagon, 2 per side. So I could just do 3 360 divided by 10. That's so much easier than 5 minus 2 times 180 divided by 5 divided by 2. Don't you agree? This angle is 36. And I got that by doing 360 divided by 10. So it's like I did 360 divided by double the number of sides. Okay, let's do trig because I know we're running out of time. All right, we've got tangent. Tan of 36 equals opposite over adjacent. X is in the numerator, so we multiply 6 times tan 36. Here's what's really, really, really important to Miss Tanton. You ready? Everyone go to your calculator and do 6 times tan 36. You get a nice long decimal. See if it'll zoom in on that. Okay. Not pretty. You keep it in your calculator. Do you go write it down and round it? No, you do not. You keep it in your calculator. What is this number? This number sitting in my calculator is half of a side. Okay, let's double it. Times 2. Now I have a new number in my calculator. That's one side. How many sides are there? 5 sides. Okay, times 5. Now you should have 43.59255 in your calculator. I'm keeping it exact. I am not rounding. What is that number? The perimeter, right? That's the perimeter. So now I'm going to multiply it by 6 and divide it by 2. Do you see how I didn't write any of those numbers down and I didn't round? We round at the very end. We're at the very end. And the number sitting in my calculator is 130.8. It said to round to the nearest tenth, so that 0.77 rounded to a 0.8. All right. That was the last example of the day. If you want to write down these two strategies, you're welcome to. You don't need to know both of these strategies. You may pick whichever one you like better for finding the angle, and you may use that one every time. This is for when it's not a special case. Not a triangle, not a square, not a hexagon. Go ahead and write whichever strategy you like better, and make sure you get tonight's homework.